exactly the same syntax, you just change 1 to 2. Then you get into this while 1 loop. So you're constantly updating the 77 display. Remember, we have 4. This one I just showed you 2. You get an idea. Once you get loop 1 and 2, you can do 3 and 4. So now you get 2 timers that's out of sync. Then you display it on the 77 display 1 and 2. Remember, there's a 3 and 4. We're not using them right now. So there shouldn't be anything going on. So if anything is changing, they should reflect on this. Okay? All right. So how do we modify the value? How do we modify the value of these? Is by using the service routine. So we scroll down more. These are the 2 service routines. See this? All right. First, return means when do we get the next interrupt? Okay. Now, when do we get the next interrupt? Period 1. We set the value of period 1 in the name, in the beginning once. And then here, we're going to reuse it. There's no need to recalculate because it's going to be the same value. Okay. Unless you're going to say, well, I want to change the timer duration. I want to change the alarm. This time I want to use 1 second. This time I want to use half. Then this value will be changed. But we're not doing that. We're doing periodic interrupt, periodic alarm, which has equal distance in time. So there's no need to change the return value. Okay? But if you put a 0 here, then the interrupt will not start again. Meaning that stop it. Okay? If you put negative values, it will not compile. Okay? Wow, you get some bizarre warning saying this line cannot be negative. You're supposed to be a positive number. Okay? All right? All right, look at this line. This line will test your knowledge about C programming. It's so parentheses. Okay? First, let's look at anything on the right. What does this mean? Very good, increment. Okay, or +1. Star parentheses, ALTUA star O close parentheses. Oh my God, what does that mean? Okay? And you're going to decipher this piece by piece. What does this mean? Yes, you want to process this as a pointer to U8. Okay, so 8-bit or 1 byte. So that means this is the, in C programming, the technical term for this is casting or cast. Okay? You cast the variable you get from here into a pointer to a byte. Okay? So you point it to a byte. Now, because we didn't know the type of the variable, so when we get the variable, we need to process it. The first thing you need to do is, what kind of variable is this? In this case, it's a pointer to a byte. How do we know that? Because in the main program, we define them as U8. So when you cast it, you have to match the type. Okay? If you use U32 here, and this value will be corrupted. Because in the system, there's a guarantee something else stored after this memory location. If you do not cast it correctly, you're going to combine the 8 bits with the next 8 bits, next 8 bit, and next 8 bit. And then this value is always wrong. Okay? And what about star parentheses, close parentheses? Yes?
It's a pointer to that entire thing.
Oh, exactly. Anybody else? So the first parentheses, this first ALTUA star means cast this variable to be pointed to a U8. This star parentheses star means
Casting the other thing.
the reference, the content of, or the value of the pointer. Sorry, the value of the variable pointed by this pointer. Okay? My alien language. Yes. You learn this from your C programming or advanced C programming concept. Okay? I know that in intro to C programming, we do not cover pointer as much detail as we should be. But definitely you get the knowledge from your advanced C programming concept. So your first operation, get the address of the variable, interpret it as a U8 first. Then tell the computer, I don't look at the address. I look at what's inside the address. Okay? So what's inside the address is actually the value of the variable. The value of the variable plus 1 equals the variable. It means what? Incrementing. So what the heck? I don't need to do this. Well, this is the way it is. Okay, to deal with it. All microcontroller system has something similar. Okay? All right? This is not the easiest one, but this one, you can see I give you an example, it works. Okay, so just deal with it. Okay. So next, if this value is bigger than 16, we set it to 0. So that means the maximum count will be 15, because you cannot see 16. The moment you see 16, you change it to 15. So the count sequence will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or A, B, C, D, F. Okay? And this value that you are changing here is this value and this value. Understand? Means this value and this value. So effectively what you're doing is you start your alarm, you respond to it when interrupt kicks in, you update the value, and then you put this value on the 77 display. So every time the time the interrupt or the alarm updates the variable, you're going to see a new value on the 77 display. Okay. So this method is using the interrupt. There's no wait or no delay loop here. In this system, there's no delay 200 milliseconds like the micro board that we have. Okay? Everything is interrupted. Right? So continue. So what's the difference between this alarm and this alarm interrupt? The only difference is one respond to one respond to two. You can see the syntax, they are identical. Just change 1 to 2. Okay? You can have 3, you can have 4 if you want. But you need to define one for each. You cannot define 2 ISR for the same interrupt. So how that? Well, how the system know which one to respond to? If you do that, the system will give warnings that don't do this. Because you can only start the interrupt or the alarm once here. If you have 2 different ISR, you need to start it twice. That means the one that will start at the latest will take over the previous one. So the previous one doesn't count anymore. It has to be this one. Any questions so far? Okay, now, I don't expect you to understand everything here right now, because your mind is occupied with assignment number 3. But this is assignment number 4. Okay. When we finish this, it will be week number, this is week number 6, right? So this is 3, this week is 4, and this week is 7. So it will be end of week number 7. There's no hardware change in terms of pins. Everything is just adding a interval timer to the system. Okay. All right. So what do you need to exercise? This is the example. So what do you need to build? You are going to build a digital clock with 4 digits, count at 100 milliseconds interval. Okay. 4 digits, right? So 100 millisecond interval, then we can see everything is changing. Okay, we're not going to sit here for 1 second, it'll take it forever to finish. So 100 millisecond interval, you can go through 4 digits really fast. And then we can still see something is changing. Okay? So you know how digital clock works. You have seen one, and you have used one. So now you need to design one. Yes.
You mean like a standard, like a normal clock, or
normal clock, 4 digits.
Well, like
you should not see number 10 A B C D F on the system.
Okay.
Okay, a digital clock. After 59, it should be 00. Okay. And we're dealing with the 4 digits only, right? So there's only 2 digits for the seconds, 2 digits for the, actually 2 digits for the split seconds, and 2 digits for the seconds. Actually, 1 digit for the split second, 2 digits for the seconds, and 1 digit for the minutes. You do 2 digits for a minute, you'll be here forever. We want to see you go through these cycles. So look at the assignment. You have